Hello everyone. Welcome to my mini lecture. Today's lesson is testing and debugging of microcontroller main control circuit. Teaching objectives. Through this lesson, you will understand and become familiar with the components of a minimal microcontroller system, and get to know the compilation and downloading processes for microcontrollers. The key and difficult point is writing a microcontroller display program. During the operation, we must adhere to safe electricity practices. Before powering up the circuit, it is essential to check for any short circuits to prevent damage to the main control circuit, which is the core of this system. Question 1. How to check the soldering quality of the PCB? What are the criteria? Since the DC-regulated power supply circuit for this task is relatively simple, with fewer than 30 solder joints, we can visually inspect the quality of the solder joints. The solder joints should be smooth, full, and shiny, without any cold solder joints or solder skips. Question 2. What checks should be performed on a soldered functional PCB before powering it up? Why is it necessary to perform these checks? How should they be conducted? Before powering up a soldered functional PCB, we should first check for any short circuits. Powering up a PCB with a short circuit can cause sparking, which may result in skin burns, or in severe cases, pose a risk of death or fire. The specific steps for inspection are as follows. 1. Before powering up the circuit, use a multimeter to check for short circuits. Set the multimeter to the ohms range times 1000 or times 100. Connect the red probe to the power supply end of the microcontroller main control circuit and the black probe to the circuit's GND, and then observe whether the multimeter's pointer points to 0. 2. If the pointer points to infinity, it indicates that there is no short circuit. 3. If the pointer points to 0, it indicates that there is a short circuit, which should be found out. Question 3. How to find out the fault of the circuit? 1. Carefully inspect the circuit's solder joints again to check if any solder bridges are connecting the joints. 2. If no solder bridges are found, use a soldering iron to remove the microcontroller chip from the circuit board, separating the circuit into two parts for further measurement and assessment. 3. Use a multimeter set to the ohms range to measure whether the resistance across the filter capacitor C1 is 0. If the resistance is not 0, it indicates that the rectifying and filtering circuit is not shorted. If the resistance is 0, it can be determined that there is a short among the components C1, C2, R1, D2, and these four components need to be removed from the circuit board for measuring their forward and reverse resistances until the faulty component is identified. 4. If the filtering circuit is functioning normally, replace it with another microcontroller chip of the same model on the circuit board, and use a multimeter set to the ohms range to measure whether the resistance across the filter capacitor C1 is 0. If it is not 0, it indicates that the original microcontroller chip has a short circuit or breakdown fault within its internal circuitry. 5. If it is not 0, then replace the LCD screen LCD12864. After powering on, write an output program to display text on the LCD screen. Check whether the main control module can download the program normally and display it correctly. Through the testing and debugging of the microcontroller main control circuit, we have enhanced our understanding of the compilation and downloading processes for microcontrollers. Here are 2 questions for you. Question 1. What are the 3 essential conditions for the normal operation of a microcontroller chip? Question 2. What constitutes the minimal system of a microcontroller circuit? That's the end of this lesson. Thank you for watching.